Good afternoon, everyone. I'm Michela Fracasso from Politecnico di Torino, and I'm going to show you a modeling study and compare to present the two mathematical approaches used for this study, and so the AV formulation and H formulation. Then the solution of a benchmark problem and the modeling result, the finite. We carried out a comparison between the data obtained with the A formulation and that obtained with H formulation. Also, in this case, we implemented the H formulation by means of constant multiphysics, in particular with the PDA model. In this case, so using H formulation, the power law is used in order to describe the superconductive behavior. Also, in this case, the critical current density, Jc, is expressed as this exponential equation, and we set n to 100. Basically, H formulation uses the finite element method to solve Faraday's equation, and rho for the superconducting domain, as I said before, is expressed as the power law, while for the air domain, rho is set equal to 10 to 7. We implemented the comparison for simple geometrical situation, and so for superconducting tube. As the first approach along and an axial field, only superconductive shield is to superimpose a ferromagnetic shield. And we studied the height, the ferromagnetic height dependence of the at three different values. Improve the shielding performances for both the applied magnetic field direction, for high applied magnetic field, but focusing on the low applied magnetic field, the shielding performances depend on the field orientation. For this reason, the second step is to study the shielding performances of the third geometry that how we can see by this picture is the configuration that with base up to 1.0 Tesla, and near the close extremity we obtain a shielding factor greater than 10 to 4 up to 1.0 Tesla of applied magnetic field. Region up to a field of 1.2 Tesla. Axial orientation, but in this case adding the ferromagnetic shield, first a shielding factor equal to of the shield where the enhancement is almost dependent from the angle, while it increases with the angle near the open extremity. Thank you for your attention.
Thank you very much for your interesting presentation.
Thank you for your presentation. I have one question. The shielding concerns the DC magnetic field, I guess. So the modeling using the AB formulation and the H formulation, in this case it's clear that the AB formulation will be more efficient because the H formulation is mostly dynamic, is more suitable for dynamic cases. I don't know if my question is clear. Why do you make such comparison?
Oh yes, the comparison is we decide to make the comparison first of all because we were able to validate the A from with experimental data. I show
Mhm.
for two omni-tube superconductors, only cap superconductor, and hybrid configuration. But this validation was carried out, first of all, only for the axial field configuration and transverse field configuration, because experimentally we were not able to measure different tilt angle of the applied magnetic field. And second, from this validation, we were able to measure only with probe on the axis of the geometries, and we were not.
Sorry to interrupt you. You are shy. How do you
It's
choose the
a
mesh?
big
The
deal.
mesh. Mm.
Yes, it's a big deal for
For,
us. I mean, in order to converge the
Mhm.
simulation using H formulation, it was needed to use mesh course, more coarse than the A formulation. And of course, this is a problem because the set always for the.
And